In this video, I'm going to talk about Michaelis-Menten equation. If this is your first time coming across a video or visiting our channel, don't forget to like, share, and subscribe. It's very, very important. Now, I'm going to use this three diagram that you're seeing here to explain the assumptions that are actually involved in the derivation of Michaelis-Menten equation. And this one that you're seeing here, I'm going to use to explain the behavior of enzyme catalyzed reaction. Now, first thing that I'm going to show you guys that in this particular beaker, because I'm going to call this guy here, I'm going to call it a beaker, right? It's just like I'm carrying out this experiment in a beaker. You understand? So this guy you are seeing here is going to represent my free substrate, right? And then I'm going to represent this one as my enzyme, right? So that basically means the molecule in blue represents my what? My free substrate. The one in red represents what? The free enzyme. And the one here, which actually represents both blue and also what's red, joined together, is going to be my what? Enzyme-substrate complex, right? And according to Michaelis-Menten, it basically says in an enzyme catalyzed reaction, right? Enzyme will bind to substrate to form in, and let me just simply say reversible manner, right? To form what we call enzyme-substrate complex, which further dissociates to give us what? Enzyme and also what? Product. This is basically everything that is happening in enzyme catalyzed reaction. The enzyme will first bind to substrate, then followed by what? The formation of enzyme-substrate complex, then this guy is going to split into what? Enzyme and also what? Free product. Now let's focus on this guy. Now the first assumption, as far as Michaelis-Menten is concerned, is basically the initial rate assumption, right? That's going to be the first assumption, the initial rate assumption, right? That is the assumption of the initial rate. This particular assumption is actually very, very important to explain the initial velocity of the enzyme catalyzed reaction. Now look at this. We have enzyme joining or attaching to substrate to form what? Enzyme-substrate complex. This is basically forward reaction, and there is always what? A rate constant. And rate constant here I'm going to represent as K1. The one that moves towards the backward side, I'm going to represent as K minus 1. And this guy here I'm going to represent as K2. Now, one thing that happens is that whenever we want to talk about the initial velocity is just implying that, okay, the velocity at the beginning of the reaction. And whenever we want to explain the velocity at the beginning of the reaction, it basically means there is no end yet. That is, there is no end reaction yet, right? Are you following me? So what it means is that if you are trying to talk about the rate of reaction of this particular experiment that you are seeing here, right? Of this particular reaction you are seeing here, enzyme plus substrate gives us ES complex, which further related to this guy. This is the end of the reaction. So what it means is that this guy and this guy cannot move back to form ES complex as far as initial rate is concerned. And I'm going to explain the reason. We said initial velocity. We want to explain the initial velocity of the enzyme. The velocity at the onset of the reaction. So it basically means we are going to be talking about the beginning of the reaction, right? So this is there is no end yet. And in that case, if there's no end yet, that basically means enzyme and product cannot react together to give us what? ES complex. It's not possible. So that's the reason why that this particular constant, they are supposed to represent the constant here as K minus 2. But since there won't be any end reaction initially, I'm going to rub this guy off, right? So it basically means that, sorry, I'm using my hand. It basically means that there is no end reaction initially, right? And I don't have any constant for it. So in that case, my initial velocity, according to Michaelis-Menten, is going to be V naught, right? Equals what? K2, right? Times what? Times EX. Just like I'm trying to write out my rate constant, right? And the rate constant for the rate equation for this particular reaction, only this guy, is basically K2 times what? ES. And that's basically what? The initial velocity. So that's going to be the first assumption. I'm going to call this bad boy here A, right? Exactly. Now let's come back to this diagram. So what this means is that if you look at this diagram very well, this beaker, you will notice that I only have the blue and the red molecule, right? That's making sense. And this blue and red molecule actually represent my enzyme and also the substrate. There is no more black molecule. And black molecule here represents what? Indicates that, okay, this is actually what? Product. So in this scenario, in the first beaker, there is no formation of product. Right, so I basically use this beaker to explain the initial rate of the reaction. That is, at the onset of the reaction, the molecule that we are going to have is what? Is the enzyme and also the substrate. Right, the initial rate of the reaction is basically the formation of rate of formation of ES. Are you seeing that is the rate of formation of ES is basically what the initial velocity, that is the initial rate, and this is basically what you're seeing here. Is this what you're seeing here? Now from there, the second beaker, right? Once again, this my what? This is going to be my substrate, or you basically say free substrate, and this is going to be my enzyme, right? This is going to be my enzyme substrate complex. Let me just represent that as the X, right? So I think I need my X. Now, what happened here is that if you look at this beaker, this second beaker very well, you notice that I'm having enzyme, right? I'm having enzyme substrate complex and also my free substrate, and at the same time, I'm having additional molecule here, which is basically the product, and it's actually what in the black is the one that you're seeing in this black, right? This is going to be my product, right? So in this case, I'm going to use this part, this beaker to explain another assumption. And what will I call this assumption? Right? I'm going to give you the name in a moment. So now let's come back here. If you look at this very well, we have substrate concentration here. Substrate concentration here is here, right? And we have a substrate concentration here. Also, we have substrate concentration here. But if you notice, we have what? We have just 3 enzyme molecules that are free. So what basically happened here is that the enzyme concentration, let me say the substrate concentration is increasing. Then if there's increase in substrate concentration, what's going to happen to the reaction? That's what I'm going to explain now. If there's increase in substrate concentration, right, the reaction will proceed forward is going to move very, very fast, right? That's because we are increasing substrate concentration. And don't forget that substrate is part of what can actually affect the rate of enzyme catalyzed reaction. Are you with me now? Now let's just come back here. So from here, if you notice, what is the total enzyme from this case? The total enzyme, so in that case, I'm going to call this particular assumption, well, let me just call it the total enzyme assumption, right? Although there's not like total enzyme, I'm just using it to explain Michaelis-Menten in general so that you guys can actually understand it. So if I call this one total enzyme assumption, what is the total enzyme here? The total enzyme here, if you notice, we have what? Substrate here, we say have what? Free enzyme molecule. Are you with me now? So enzyme total here, right, is going to be 2, right? It's going to be what? Our free enzyme, right, which is E. Are you with me? Then plus the enzyme that bond to substrate to form what? ES complex. So I'm going to have what? ES complex here, right? So that's basically what we have. So enzyme total concentration. Let me just represent as concentration because it's very, very important, right? Concentration of enzyme total equals what? Concentration of the free enzyme plus what? Concentration of the ES complex, and that's basically what we have. Hope you guys are following. Now that's just the next case that we have. Now let's quickly move to this particular last speaker here. It's actually the one that is very, very important. It is very, very important. Very important. Now look at this. We have only enzyme molecule here, right? Once again, this is going to be about my enzyme, right? Now, one thing I want you guys to understand is that as we keep increasing the substrate concentration, it will get to a particular point where all the active sites will already will be occupied. That is a particular point where all the active sites will be filled up with substrate molecule, right? So what happens is that look at this. Here, attached to this particular free molecule of enzyme here, I'm going to have what? A substrate. Attached to this, I'm going to have what? A substrate. Attached to this, I'm going to have what? A substrate. Attached to this, I'm going to have a substrate. Attached to this, I'm going to have what? A substrate. Attached to this is a substrate, and this is a substrate. So at this particular point, what do you notice? All the active site of the enzyme has already got to be occupied. Then what happens at that point? At that particular point, the rate at which enzyme is dissociating, or let me just say the rate at which ES complex is what dissociating to form enzyme plus products is equal to the rate at which what enzyme plus substrate is forming what EX. I'll go back again. This lab speaker is just telling us that okay, all the active sites. What happened when all the active sites has already been occupied? What basically happens is saturation, right? So that's why I'm going to call this particular last one saturation assumption. Are you with me now? But it is actually the main one that we need because all the active sites has already been occupied. At that point, whenever active site has been occupied at that point, the velocity, which is the initial velocity, is going to what? Is going to reach the maximum velocity. Are you with me now? So and at that point, what happened at that point? The rate of formation of EX is equal to the rate of deviation of ES, and that's basically where they are going. That is, if this reaction is still going on, what is going to happen? The rate at which this substrate is detaching from this particular enzyme will be equal to the rate at which they are forming back. Are you with me now? So at that point, if you notice there is no more free enzyme again, right? Because all the enzymes, as they are detaching as they are releasing the products, they are picking up what? Another substrate. As they are releasing what? Products, they are picking up what? Substrate. Let me just write it as this particular, as this. We are having what? E is picking up what? S to give us what? ES. Abina. Then as this guy is what? Is forming what? E plus P. Don't forget, enzymes are not always used up in the reaction, right? So as this guy is what? Is detaching, we are adding another what? Another substrate, right? Another substrate what? Is added to it. So what basically means that the rate at which what? At which ES what? Is formed is equal to what? To the rate at which what? E, this ES derivates what? To give us what? E plus what? Plus P. Are you with me now? So in that case, I'm going to have what? I'm going to have E, enzyme and also what? Substrate that band together. Abina, and I'm going to have free substrates. Why am I having free substrates? That's because, right? That's because I'm increasing what? The concentration of the substrate. I'm having concentration of the substrate, and I'm keeping the concentration of the enzyme. I'm keeping it constant, right? And don't forget, enzymes are not always what? Used up. Once enzymes are not always used up, but like if enzymes are not always used up, the active site has already what? Been occupied. Why? Because I'm adding substrates, right? So in that case, I'm no longer having any what? Free enzyme again. And if I'm not having free enzyme, what does that mean? It basically means this guy here is going to change. Why? Because in this third beaker that you're seeing here, this particular concentration of the enzyme, of the free enzyme, is equal to what? 0. And if it is equal to 0, what's going to happen here? This guy is going to what? Is going to be 0. So that basically means our enzyme total here is going to be equal to what? EX complex. Right? So this is basically the theory formula that I'm going to use to derive Michaelis-Menten equation. And I know that you guys actually enjoyed this video. So I'm going to pause this first one here and continue in the next video. Thank you for watching.